Yeah, hi guys, welcome to the present session. So I hope
Yeah,
my
hi guys, welcome to the present.
I hope my audio and video both these two are fine, guys. So if you're feeling any problem with the audio and video, then please let me know. I mean, you have to just put your comment in the comment section, okay, so that I can rectify, guys. Uh, so we will wait for 1 minute and then we'll start the session. Why? Because few more candidates has to join it. Fine. Yeah. So we will start now. So before going into the main content of this video, myself, I am Aswini Kumar, the educator of electronic science as well as general paper 1. So here Unacademy is providing the free online classes as well as the paid courses also. So free online classes you will get in the two platform. One is in the Unacademy YouTube platform and another one is in the Unacademy app. So if you open the Unacademy Learning app, then you will get the special classes. These are the free classes, guys. And in the YouTube also, just know whatever the class is going on. So these are all the free classes. And paid courses are also providing by the Unacademy. The two different subscriptions are there. One is the Plus and second one is the Iconic subscription. Fine. So here, the candidates who are looking for the NTA UGC net free online classes for paper 1 as well as for the paper 2 electronic sciences. So here on the Unacademy platform, it is a Telegram group link, guys. Okay, so ASWINI UGC NET 88. Okay, so UGC NET 88. Okay, it is a Telegram group link, so all the interested candidates may join in this group to get the updates regarding the free online classes, as I told, the special classes as well as the YouTube platform. And next, at present I'm giving the 6 different courses in the Unacademy, guys. So first one is complete course on paper 1 and electronic science. It started on 12th July and closes on 12th August. And the next one is electronic science previous year question course, started on 5th July. And the MCQ course on paper 1 started on 20 minutes. It's going to start from 21st July onwards. And the MCQ course on electronic science July 25th onwards. And crash course on paper 1 August 18th onwards. And crash course on electronic science August 18th onwards. Fine. The candidates who wants to get all these courses, okay, take the subscription plan, and whatever the necessary links are there, all the links are kept in the description box of this video, so you may check out, guys. Fine. And whatever the current plans are there, that means these are the subscription plans. Okay, you may take 1 month, 3 months, 6 months, 12 months, or 24 months. Okay, whatever the plan you want, you may take these plans. And here you may use my referral code ASWINIKLIVE. Okay, if you use my referral code, then you will get the 10% discount on the subscription, any one of the subscription plan, guys. Okay, no problem. And here, whatever the subscription plans are there, of subscription plan you will get 2 months extra. If you take 12 months of subscription plan, you will get 2 months extra. That means you are paying only for the 6 months or 12 months, but you are getting the additionally 2 months extra you will get. Fine. So these are all the things, guys. And whatever the paid courses all there in the subscription plans, you can download the class PDF, and online classes will be there. You can clear your doubts. Okay, and the doubt clearing sessions also will be there. Okay, and the test series are also there, so which will be complete backup to crack the JRF, guys. So utilize this opportunity. And if you're planning to take the subscription plan, then use my referral code, then you will get the 10% discount on any one of the subscription plan. Okay, and now we will start our session. today's session is microprocessor, correct? Microprocessor. So actually most of we are feeling difficult about the microprocessor, right? So but we will try to understand very simple way about okay, what exactly the microprocessor is. That means I'm going to give you the in brief, okay, the details, everything we discussed in the plus classes, guys. Fine. The first one is, 1 minute I will take. So good morning to all of you, the candidates who are watching this video. So if you are having any doubts, then you may put your comment in the comment section. I'm watching the comments, guys. So 8086 is a microprocessor, okay, which is supporting the multi-purpose programming logic device. Fine. And here it is having the 29,000 transistors are there, and it uses the HMOS technology. HMOS technology is nothing but a high-speed MOS technology. Fine. It uses the high-speed MOS technology. And 8086. So while coming to the microprocessor means, what mean microprocessor means? Which can able to process the instructions or mnemonics in microseconds. Okay, that's why we are calling as a microprocessor. That means for executing, yeah, hi Arti, good morning. That means for executing the instructions, we are taking the very less amount of time to execute the instructions. Why it is taking less time? Because the architecture of the 8086 microprocessor is like that. So based upon that architecture, very less amount of time is taking to execute the instructions, right? And next, 8086 is designed with high speed NMOS logic family. Okay, high speed NMOS logic family we are designing with. And next, it is the first processor which is supporting the pipelining concept. Pipelining. Okay, what is the meaning of pipelining? How come the pipelining will increases the speed of the processor? Means I will tell you what is the pipelining concept. Generally, if you are taking any one instruction, but as per the assembly level language, we are calling the each and every instruction as a mnemonic, right? Mnemonic. So mnemonic means it is some Greek or Latin word. The original our English meaning of this one is that mnemonic is nothing but a memory related. Why we are calling this one as a memory related? Because whatever the instructions we are writing, we are storing those instructions into the memory, right? That's why we are calling as a memory related, and in other language we are calling this one as a mnemonic, right? And now, for example, if I am writing move AX comma BX, something like this, any one mnemonic or the instruction if I took, then here first of all this instruction has to be fetch from the memory, correct? Instruction has to be fetched from the memory, and after fetching, next what has to be happen? Okay, decoding. Instruction decoding has to be happen. Decoding means what is the opcode, what is the operand, which type of operation has to be performed on the given operands. That means decoding the opcode and the operands. Okay, because here in this instruction, move is a opcode, and AX comma BX are nothing but operands. Okay, it means which type of operation has to be performed on the operands is decided by the opcode, right? And so that is called as a decoding. That means separating the opcode and the operands. And after the decoding, next execution has to be done. Okay, after the execution, we will take the write back and the memory stages will be there. Okay, write back or memory stages. But usually I'm just focusing here only on the 3 stages, that is fetching memory, decoding and execution. After the execution, whatever the result you got, that result will be stored into the some registers like that. I'm calling that one as a write back. Right? So now in this case, if I took the 4 instructions, first instruction, second instruction, third instruction and fourth instruction. So here we are dividing, it is 1 stage, second stage, third stage and fourth stage. Okay, so now instructions are like this. If the first instruction is in the fetching stage, then 2, 3, 4 will be in the idle stage. Next, if the first instruction is in the decoding stage, that I'm calling this one as a ID, and I'm calling this one as a IF, fetching, and I'm calling this one as a IE, and I'm calling this one as a WB. If the first instruction is in the decoding stage, then the second instruction is in the fetching stage, and both these two will be in the idle stage. Now, if the first instruction moves to the execution stage, then the second instruction will move to the decoding stage, and third instruction will be in the fetching stage, and fourth one is in the idle stage. Next, if the first instruction moves to the write back, okay, moves to the write back stage, then the second instruction moves to the execution stage, and the third instruction moves to the execution. Third instruction moves to the decoding stage. Fourth instruction moves to the fetching stage. That means at one point all the instructions are doing some work. Correct? Okay, so it is called as a pipelining concept. Okay, without pipelining, how the execution will happen? Without a pipelining, if the first instruction gone through fetching, decoding, execution, write back, then only the second instruction will start fetching, decoding, execution, write back, and then the third instruction fetching, decoding, execution, write back. That means until completion of the first instruction, all these 4 steps, the second instruction will kept in the idle stage. That is without pipelining. So definitely without pipelining means it will take much time to execute. Correct or not? So that's why this pipelining concept, that means each and every stages, fetching, decoding, executing, write back, and here all the instructions are sharing the different stages, right? It is called as a pipelining concept, so that we can able to increase the we can able to decrease the execution time. That's why within microseconds we can able to execute the instructions. That's why it is called as a microprocessor. I hope all of you understand what is the meaning of the pipelining concept and how come this pipelining concept is helpful to increasing the speed of the processor or else to decreasing the execution time. Right? And if you go to the architecture, one more device is also there, that is called as the instruction queue. Instruction queue is also helpful for the speeding up of the operation of microprocessor, that we will see in the next stage. Fine. Okay, pipelining concept. And next, 8086 is having the 16-bit data bus, and it is having the 20-bit address bus. Okay, 20-bit address bus it is having, and it is a 40-pin dual-in package IC. Okay, so now 20 bits address bus is there, means what is the memory capacity? 20 bits address bus, 20 bits address bus. What is the memory capacity of this one? Memory capacity is 2 power 20. 2 power 20 means 2 power 10 into 2 power 10. We can take this one as a 1024 into 1024, that we can take as a 1 MB. That means the size of the memory of 8086 can be taken as a 1 megabyte. And this 1 megabyte of memory of 8086 microprocessor is divided into 4 segments. Okay, it is divided into 4 segments. That means if you take it as a memory of the 8086, which is having the capacity of 1 megabyte. It is divided into the 4 segments like this. And what are the 4 segments means? One is the CS, another one is the DS, next one is the ES, next one is the SS. What is these things? What is these things means? CS is the code segment, DS is the data segment, ES is the extra segment, and SS is the stack segment. And the size of the each and every segment is 64 kilobytes. Understand? Size of the every segment is 64 kilobytes. Okay, it is a segmentation of the memory. Now, code segment of the memory stores what? It stores the instructions. Understand? It stores the instructions or the mnemonics. Data segment stores what? The name itself it is telling. It stores the data. Why? Because if you want to add AX comma BX means in the BX some data must be there, in the AX some data must be there. Both these two data has to be added and the result has to be stored into the AX. From where you will get the data? From the data segment you will get the data. Understand? From the data segment you will get that data. Now, what is the extra segment? Extra segment is that if the data is completely filled in the data segment, then what about the excess data? That additional data can be stored into the extra segment. That means extra segment acts like extra to the data. Understand? If the data segment is completely filled up with the data, but if still more data is there to store, that will goes to the extra segment. Right? And next, what about the stack segment? Stack segment is that whenever the programs are running, that means for example, you are doing some work in your laptop. Suddenly I open the disk drive to put one disk. Then what will happen? Okay, whatever the program is executing, it will go to the disk drive and it will do that function and it has to come back to execute your routine program. And here the disk will come out. I mean the disk drive will come out, right? So that is nothing but it is called as an interrupt. Okay, interrupt. Why? Because whatever the current work it is doing, and at this point you give one interrupt by pressing the button of the disk drive, and then it will go to execute it goes to the disk drive and does its work and then come back to execute the present instruction. Right? So whenever such type of interrupts are given, then whatever the next instruction to be fetched, or else whatever the instruction that left here, okay, that instruction address and the data, everything will be stored into the stack segment. And after servicing the interrupt, it has to come back to this instruction to fetch, right? And how it can able to find out it is the next instruction after the servicing the interrupt routine means by getting the content from the stack segment. Okay. Yeah, hi Mano, good morning. I hope all of you understand what is the purpose of the each and every memory segmentation. Fine. So it is a dividing of the memory segmentation. Fine. Now, coming to the architecture of the 8086 is divided into how many parts? Architecture of 8086 is divided into 2 parts. One is bus interface unit, another one is what? Execution unit. Okay, bus interface unit and the execution unit. Both these are the 2 different parts. We will see about what the bus interface unit will contains, what the execution unit will contains. But before going into this one, I will just tell you here. I told that the 20-bit address will be there to the 8086. So 20-bit address means how we can able to collect the data or the instruction from the memory means, see guys, let's take one decoder. How we are going to take the size of the decoder? It is n by 2 power n, right? So I am taking 20 by 2 power 20. That means how many inputs I can take here? How many inputs I can take? 1 to 20. 2 power 20 means how many outputs I can take? Starting from total from here to here. Starting from 1 to 1024 into 1024. Am I correct or not? That means 1 to 2 power 20 outputs I can take. And here I will connect the memory. I will connect the memory. That means if it is the first location and it is the 2 power 20th location. So now we are connecting the each and every wire like this. Okay. So for example, here the operation of the decoder is that if you are making the first bit as a 1, then this one will be enabled. Okay, this one will be enabled, and whatever the content present in this one, that content will come out. Then nothing but a fetching. Okay, you can fetch that means by controlling the inputs of the decoder. Okay, by controlling the inputs of the decoder, you can able to access code segment, data segment, extra segment, stack segment. Understand? You can access anything. Why? Because if you take that is a, I mean, I can't show the 20 by 2 power 20. I will just show you 2 by 4. If it is a 2 to 2 square, 2 by 4 decoder, then how the inputs and outputs we will get? See, I0 and I1, these are the two inputs, and outputs are 4, Y0, Y1, Y2, Y3. If it is 0 0, then Y0 becomes is equal to 1, all the remaining 0. If it is 0 1, then Y1 becomes is equal to 1, all the remaining 0. If it is 1 0, then Y2 becomes is equal to 1, and if it is 1 1, then you will get like this. That means Y0, if you want to activate the Y0, it depends upon your input combination. If you want to activate the Y3, it depends upon your input combination. So like that, whatever the data, whatever the code, whatever the stack related thing you want to access from the 8086 memory, you have to properly control this 20 bits. Understand? So these 20 bits are called as a address bits. It is how the address bits are connected to the memory locations. It is how we can able to access the content present in the memory based upon the 20-bit address. Okay, I hope all of you understand. Right? Next, we will go back to the architecture. So coming to the architecture of the 8086, as I told that it is divided into the two parts, and yeah, it is the architecture. Fine. So here, just a minute, guys. Yeah. So coming to this one, we are having the two stages as I told previously. One is a bus interface unit and second one is the execution unit. Fine. So we are having the two different stages are there. And coming to the bus interface unit, we are having the extra segment, code segment, stack segment, data segment, and instruction pointer. Fine. We are having all these three. And you may get one doubt that extra segment, code segment, stack, and data and instruction pointer is there. Okay, these are the different segment registers. I mean, segments are there. What are these segments? And what is the memory thing? Here I told that the memory is divided into the 4 different parts, correct? Fine. The memory is divided into the 4 segment parts here: code, data, extra, and the stack segment. So by this concept, you will feel that ES, CS, SS, and DS is the memory, but it is not the memory. Did you understand? It is not the memory. Fine. These are all the registers: extra segment register, code segment register, stack segment register, data segment register, and the instruction pointer. Fine. And what these registers will hold actually? What these registers hold means, I will tell you. Yeah. Have a look here. Code segment register, is it visible to all of you? Code segment register holds the, these are all the registers which are placed in the bus interface unit of the 8086. Code segment register holds the starting address of the code segment of the main memory. Did you understand? Next, here data segment register holds the starting address of the data segment of the main memory. The same thing, extra segment and the stack segment. So by this, all of you understand what is the code segment register, what is the code segment, what is the data segment register, what is the data segment, extra segment register and extra segment, stack segment register and the stack segment. All of you understand the difference between both these two first of all. Okay. Now, one more little bit modification. What is that one? And regarding what? Previously I told that code segment register is used to hold the starting address of the code segment. But here, if you observe, the starting address of the code segment is 34BA0. But here what it hold? Only 34BA. Okay, that means code segment register is not going to hold complete 20 bits of the starting address of the code segment. It is going to hold only the upper 16 bits of the starting address of the code segment. All of you understand? Fine. So the same thing for the data segment register as well as the extra segment as well as the stack segment also. Fine. So these registers, code segment, data segment, extra segment and the stack segment registers are used to hold the starting address of the corresponding segments, but not complete 20 bits. They are going to hold the higher 16 bits only. Understand? Higher 16 bits only they can able to hold. Fine. That's what they are representing. Okay. So now these registers are located in the what we call in this one. Fine. Now bus interface unit. So we discussed about all these different segment registers. Okay, and the instruction pointer which is used to hold the address of the present instruction that is going to be executed, and here it is the instruction queue, okay, which is used to hold the next 6 instructions that is to be executed, and it is the adder which is used to calculate the physical address memory location of the 8086 with the help of offset address, and it is the execution unit, and these are the different general purpose registers, ALU and the operands and the flags. So execution unit contains the control system, ALU, general purpose registers, pointers, index registers. Fine. And bus interface unit contains this one and this one. Fine. So it is a just in brief introduction to the architecture of the 8086. Fine. Okay, so as a half an hour session, by this I am closing this session, guys. Okay. And we will meet in the next session. So our next session is, as I told, every week, Monday, Tuesday, Wednesday, morning 11:30 to 12 o'clock. It is our YouTube session timings, guys. So if you want to get the more details and the complete details regarding this one, you may take the Plus subscription. Okay? And as I told that these are all the present courses are running in the Unacademy. Okay, so the interested candidates may take the subscription plan. The prices are going to be increased today night, so please hurry up. Okay, if you're planning to take the plans, fine, and use my referral code. So it is my referral code, then you will